Deep isolation, we've passed that point now where this is going to happen. It's a question of when, not if. And the timeframes, yes, are a little bit uncertain. There is a regulatory process that we have to go through, but it's not a particularly difficult one. So if you compare this to other pieces of the nuclear industry, where I think there's a lot more uncertainty and timeframes are longer into the future, I think within the next couple of years, we're going to start to see where this is going to happen and when this is going to happen. And I'm not talking about 10 years in the future. I'm talking about 3 to 5 years into the future.
Just because the facts are A, if the narrative is B and everyone believes the narrative, then B is what matters. But it's our job in our industry to speak up proudly, soberly, and to engage people in this dialogue. Those 2.5 billion people that are in energy poverty, they need us.
America cannot meet this threat alone.
If there is a single country,
of course, the world cannot meet it without America,
that is willing to
but we're going to need you, the next generation, to finish the
overhaul
job.
nuclear regulation
We need scientists to design new fuels.
and focus on net public
We
benefit
need engineers to invent new technologies. We
over absurd levels of radiation
need
protection,
entrepreneurs to sell those technologies.
then we will march towards this.
We need workers to operate assembly lines that hum with high-tech, zero-carbon
We have
components.
unlimited prosperity for all humans.
We need diplomats and businessmen and women and Peace Corps volunteers to help developing nations skip past the dirty phase of development and transition to sustainable sources of energy. In other words, we need you.
Okay, welcome to another episode of the Fire Division podcast, where we talk about energy-dense fuels and how they can better human lives. Today, we're joined by Liz Muller, the CEO of Deep Isolation. Liz, how you doing today?
I'm doing great. Happy to be here, Mark.
Excellent. Before we get started, why don't you give a 60-second elevator intro to yourself? You've been public previously on a bunch of other podcasts and interviews, but I'd love to just get a quick background on you before we kind of dive into some other technical topics.
Yeah, I'm here, and I started Deep Isolation because I do want to do something about climate change. And I think that nuclear has got to be a big part of the answer. I don't think there's any way around that. And I lived in France for a number of years. I grew up in a nuclear-free zone in Berkeley, California. And I never really understood the controversial side of nuclear. And a lot of that is around the waste, people objecting to this unsolved problem. And the nuclear industry explaining why it's not a problem, it's very safe, it's so small in volume. And it seemed to me that rather than try and explain why we shouldn't consider the unsolved nuclear waste problem not a big problem, why don't we just solve it? Why don't we just fix it? Why don't we just do what we should be doing anyway? And that really led to the formation of Deep Isolation.
I've long thought that coming from oil and gas, we put a lot of waste back into the earth
Yes.
in the subsurface.
Yes.
And it confused me for a long time why we couldn't also do this with other hazardous materials. We'll dive into that a little bit more, but before you got to Deep Isolation or started Deep Isolation, you had several leadership roles in your career. Give us a little bit of background on that.
I started out at the OECD in Paris, so working with governments around the world on controversial technology problems, not yet in the nuclear space, not even really in the energy space. After that, moved into consulting and got more into energy. And this global warming issue just kept coming up. Countries around the world trying to figure out what can we do if we really want to be responsible and address climate change. Had a brief bit of experience in the oil and gas sector myself, trying to help other countries who have not actively explored their shale resources figure out how to do that. And then from that led directly to Deep Isolation, using the same technology that you use in the oil and gas industry, but to solve this massive unsolved problem of nuclear waste disposal.
Gotcha. Yeah, oil and gas. Yeah, we've got a lot of solutions. And it looks like you're sitting in a library today, but I'm actually in the field right now where the oil and gas action happens.
Yeah, I love it.
Yeah. So I want to dive into Deep Isolation. Why don't you briefly describe the technology? And then I've got a list of questions that I've been curious about from your guys' technology and the approach that you're taking.
Yeah.
What's your proposed solution?
Deep isolation is really using existing mature technology from the oil and gas sector, specifically around directional drilling and using boreholes for the disposal of nuclear waste. The idea of using boreholes for nuclear waste disposal has been around as a concept since the 1980s. Nobody's ever done it. Nobody's ever disposed of high level nuclear waste or spent nuclear fuel, period. But most countries that are moving forward are doing it in an underground repository. So this is still a mine. You mine out a cavern, you have people underground, you need to worry about air, you can't go that deep because you have to be able to have humans underground. Whereas today, with directional drilling, why would you put humans underground when you don't need to? And if you don't have humans underground, you can go deeper, you can remove less rock. Nuclear waste, as many people have pointed out, is incredibly dense. So you don't need a big cavern. An 18-inch borehole is really just about perfect for the disposal of nuclear waste.
Gotcha. I couldn't agree more. I've worked in a mine and I've drilled a lot of wells. And
Yeah.
yeah, it makes a ton of sense that, like, why would you build this whole system that humans can walk into when all that you need is like a storage system? Now, just looking at the geometry of both the, we'll say, dry cask storage and what I think of as a conventional borehole or conventional bore, there's a mismatch in geometry, right? Meaning we store these rods in large casks, and the holes that you guys are presumably going to drill aren't that big. What's the strategy there? Are you guys going to take the fuel rods out of casks?
So we could. So the fuel rods, the fuel assemblies are really the unit that we would want to work with. So one fuel assembly per canister that you then lower down into the hole. So if the fuel assemblies are still in the pools, the cooling pools, then we can take them directly out of the pools, put them in the canister still underwater, and then bring them out and put them directly into the borehole. If they are in the casks, then they would need to be opened, but we're trying to minimize the amount of repackaging that is required. And so we're currently thinking one fuel assembly per canister. Now, eventually, we might get to the point where we want to repackage it and have it be even more dense. You can fit a lot more fuel in a canister if you repackage it. But that's not where we want to start. We want to keep it as simple as we possibly can. And we think that is going to be one fuel assembly per canister.
And so when you said fuel assembly, this is the actual zirconium cladding, or it looks like angle iron to me, but the rectangular tube that then you've got the ceramic uranium pellets that are inside of, and that's the actual spent fuel and fission products. But you want to just take the whole rod, the angular rectangular cladding, and then put it into a separate cylinder that then, hey, that package you can just install into a wellbore.
Yeah.
Is that separate package then shielded, or provides adequate shielding that it can be handled?
So it would be shielded above ground. Once you put it underground, you don't need the shielding anymore. So the shielding doesn't go underground with the canister itself. But when you're handling it above ground, you do have the shielding.
Gotcha. So do you guys have a proprietary mechanical system to vacate them when you install them in the well? How does this work?
We don't. So there are handling techniques that already exist. So people do handle spent nuclear fuel today. They take it out of pools, they put it in dry casks. Sometimes it needs a bit of repackaging. There are transport mechanisms. We don't want to invent anything when there's something that already exists. NAC International is a partner of ours. They do a lot of this work. We'll be drawing pretty extensively on that work in order to put it into our canisters. And then once it's underground, you don't need the shielding anymore.
Gotcha. And I can probably ask one of my mentors this, but the process for actually removing it from dry casks, that we know how to do that now, right?
We do. There's a couple different ways you can do it. You can do it above ground using a shielded room. You can also put it back in the pool if you have a pool available and open it up underwater. So there's a couple of different existing mechanisms for that.
Okay. And we've heard there's a target of 50 years, or 50-year target to be able to retrieve rods. Why was that target set? What's the history behind that?
Yeah, so the 50-year number is not a hard number. This is the number that was developed when thinking about Yucca Mountain. So if you look at the actual regulations themselves, what they say is that the waste needs to be retrievable until the repository is closed and sealed. Now, for Yucca Mountain, it was going to take 50 years to fill and seal the repository, so it needed to be retrievable for 50 years. Now, with a borehole, you don't need 50 years to fill a borehole. You need maybe 1 to 3 years, depending on the size of the borehole. So we think this is a gray zone where there are arguments that we could make that we don't think it should need to stay open for 50 years. We could keep it open for 50 years, but I think it makes a lot more sense to have a performance confirmation period of maybe a couple of years, maybe as much as 5 to 10 if you really want to study a lot of things, but then you seal it up. It shouldn't need to be retrievable after that. You either remove or you perforate and destroy the casing, after which point you really don't want it to be retrievable. So you go from a period when you want it to be retrievable to a period when you want it to be resistant to proliferation risk. And so you really don't want anyone to be able to get it after that.
Yeah. All of the enhanced breeder reactors and thorium guys I can hear them screaming, no, we don't want to put it underground. That's
Don't
all.
put it underground if you still want it. So I think if you want to do reprocessing, if you want to use this as a fuel for advanced reactors, get the parts that you want first. Those same people will tell you that what they really want is the most recent fuel. So the new stuff, the hot stuff is what they want. And the older stuff, they're not going to be so interested in. And we're still generating more. So I think there's plenty of waste for everyone who's going to want it, and a lot more that's just going to need to go into disposal. So we don't want to dispose of it if anyone wants it, but the stuff that they don't want, let's go ahead and start putting it underground.
Got it. Yeah. Are there any exotic casings or metallurgy? We use the word casing and people sometimes don't understand what that is, but it's the steel pipe that goes and cases the well bore when you go and drill wells. And often those casings are very robust, and it's rare that they have problems or corrode, but it's possible they can. So are you guys looking at any advanced metallurgies to have special wellbore designs?
Yeah, we've looked at them. We can use them. We think that for most instances, we're not going to want to. We really like the off-the-shelf, readily available options. We know more about them. We've been using them for years and thousands of holes around the world. So I think to the extent we can, we don't want to
hundreds of thousands, right?
Hundreds of thousands. Yes, yes. So we know this technology really well. It's competitively available. That's where we want to start. Now, if there's a customer who has a very unusual circumstance, so we are talking to one that wants retrievability for up to 100 years. That's not a normal case. That's a somewhat unusual case. And in those instances, yes, we might want to look at corrosion resistant coatings and other types of metal. So we can do that for those special use cases, but we think in most cases, we're just going to let the standard stainless steel.
Got it. So what's the ideal reservoir or geologic formation that you guys might be targeting? Because in my mind, from what I know about geology, and I feel like I know a lot. My dad's a geologist. I've worked in oil and gas most of my career. I've studied geology. I feel like you can drill these wells almost anywhere. If you're not drilling through granite or super hard rock, it helps if it's sedimentary rock that you're drilling through so that you can drill faster. But realistically, like you could put these boreholes and these wells anywhere. But do you agree, or is there an optimal geology that you guys are looking for?
So I think the industry, the way that people have thought about nuclear waste disposal historically is very different because they're looking at much shallower depths. So if you're looking at 300 to 500 meters in depth, you really need a great rock formation. You need something where you can convince yourself this is not going to get out over periods of millions of years. And that means a pretty specific geologic formation that is impermeable, that for whatever reason, it's good. It could also mean some engineered barriers that you need to have in there as well to make to reinforce the natural geologic barriers. When you're going 1 to 3 kilometers in depth, you have so much more rock that is the natural barrier that you can be a lot more flexible in terms of the formation type, the rock permeability levels. Really, everything that you're looking at is easier to hit those requirements when you're at depths of 1 to 3 kilometers. What we're really looking at is not so much the particular formation, but a test of isolation. So we will want to do isotopic testing at depth to show that the water being held in the pores of the rock has been isolated from the surface for 1,000,000 years. And if it's been isolated from the surface for 1,000,000 years, that's great. That's a really good starting point for showing that this is going to be a safe place for nuclear waste disposal. What that means
And
is,
how are you going to do that testing? Is that like sidewall cores that you
yeah,
take
we'll do
samples and core samples?
exactly. Exactly. And then send it to a lab probably and do the testing. We would do
And
that
then you
before we
carbon
disposed.
date those materials, and then you can say, okay, yeah, this is how old we think this water is, and
Exactly.
we date it against the water on the surface, and yeah,
Yeah, that's right.
interesting.
And because we can do that, we think that there's much more flexibility when it comes to location. So we're not going to want to do this on top of a active volcano or a geyser or anything like that. But even seismicity isn't necessarily a significant barrier to disposal. So shaking is okay. What that means is it becomes a different question. So you're not necessarily looking at the best location or even the best locations for disposing of nuclear waste. You're looking at where are the locations where this is the most feasible. And if you think about it from that perspective, one of the issues that we see a lot of is not in my backyard. People don't want waste brought into their community, which is quite understandable. But there's a lot of communities out there that already have waste. They have waste today. It's in temporary storage in their community at the reactor where it was produced. And if you offer them a choice, they can keep it above ground where it is now, or they can put it deep underground where for the very long time frames it's going to be significantly safer. You might find that you're going to get some volunteers who might not otherwise be interested in something like this.
Okay. We'll touch on a few more technical things, but you mentioned that's a good segue into kind of communities and the definition of what a community is and who wants to house this in the future. What kind of communities are you working with, or different countries are you working with? And have you had better success with some versus the other? Because I totally agree that the biggest challenge with waste is just the community approval. We've solved all of the technical challenges, in my opinion.
Yeah. Yeah, I think so. We've been out talking to a lot of communities and locations around the world. I think there are many communities that are interested in being waste repositories, but then you still have transportation issues. In the United States, you have state issues. And so having a community that's interested is an important factor, but it's not sufficient. And I think, again, that you've got to start with the easiest problem. And I think when you have to deal with transportation and crossing state lines and bringing waste into a location that doesn't have it today, I think you're just making your problem significantly harder. And one of the advantages of boreholes is you don't have to have a waste repository for anything other than waste that is there right now. So I think that's where we're going to see the first iterations of this technology is we're going to see boreholes for disposal at or very near an existing nuclear waste site. Now, not all of those existing waste sites are going to want to have a repository in boreholes. So eventually you're going to have to move into issues of transportation and finding other locations. But I think we've got to start with what's simplest, and that's going to be disposal. And then you start to build trust, you start to build an understanding of what we're doing, and you tackle those harder problems at a later date once we've already had some successes under our belt.
That makes a lot of sense. Do you have a timeline to licensing or commercialization for when you expect that you'll be able to start trialing some of this?
Yeah, so we've already started trialing. We have a location where we're doing some demonstrations, but in terms of actual commercialization, I think so licensing is going to take at least a couple of years. We're thinking about 2 to 3 years for the first iteration to get through that process. And so we're looking at 2 to 3 years to commercial from the time that a customer says, yes, let's go, let's get this done.
That's pretty fast.
It is pretty fast. I mean,
Compared to the Yucca Mountain discussion, that's infinity,
yes,
right?
yes. It's a mature technology, as it doesn't take a lot of time to drill a well. So it's really the licensing that takes the most amount of time. And the drilling, we're talking about months. And then to in place, we're looking at a couple of years. So it's really a much faster process. And you can be doing multiple holes at the same time if you have a large amount of waste to dispose of.
Yeah. Just add a drilling rig. We know how to do this. You would only keep it in the horizontal portion of the well.
So if it's a horizontal disposal facility, we would keep it in the horizontal portion, and then the vertical portion would be plugged. For very small volumes, it might make more sense. You don't even need the horizontal portion. So vertical and deviated wells are also something that we're looking at. Deviated are perhaps the most useful for certain types of waste that has larger diameter. So not everything is going to fit into an 18-inch hole. Most spent nuclear fuel will, so that's why we like these 18-inch holes that'll fit in our 15-inch canister. But there are some vitrified waste forms. There are some other forms that would need a larger hole, and larger than 18-inch horizontal laterals are still somewhat exploratory. So we want to stick to what we know, and we feel pretty comfortable with the 18-inch horizontals, but going wider than that, we think is still require a bit of testing.
Yeah, absolutely. There seems, so circling back to this availability issue, there's a cradle to grave problem in nuclear. Similar to the HALEU supply, there's lack of disposal options. Are you working with any of the developers now to guarantee solutions, or are you just working predominantly with power plants, or who are your key customers? That's maybe a better way to ask that question.
Yeah, so in most governments, in fact, I think in all governments around the world, it's the government that's responsible for nuclear waste disposal. So even though it's private actors who may run a nuclear power plant, who build the nuclear power plant, who are very active in the day-to-day, when you're thinking about disposal, you're thinking about guaranteeing that something's going to be safe for thousands to millions of years. And so in all circumstances that I'm aware of, it is the government that is responsible for that. And so those are our customers. Now, that said, we're also working with people from other parts of the supply chain who want to make sure that they can use our solution, especially if you're in a circumstance where it's the power plant that needs to pay for eventual waste disposal. They want to make sure that waste disposal can be done efficiently and at a reasonably low cost. So interested in working with deep isolation for that. Similarly, for some of the advanced reactor companies, there's storage requirements. And if you look at storage requirements, they can build up. And so if you don't have a disposal option, that can actually get quite expensive. And it's much cheaper to just put it straight into disposal as opposed to storing it for tens to hundreds of years before then putting it into disposal.
Well, it's really like eliminating the liability, which helps the balance sheet, probably helps your insurance premiums, right? It sounds like a good financial choice.
Yeah, for sure.
So in the U.S. specifically, you guys are a U.S. company, I assume.
Yes.
And so in the U.S., when I've looked into the Department of Energy's current strategy for waste is this consent-based siting approach. And when we've researched it, their timeline for that is somewhere between 20 to 40 years for them to complete that project, which just seems like they created a career for some of the people in that department, and it's actually never going to solve the problem. Maybe that's a jaded way to look at it, but I'm curious on your perspective. Does the U.S. stand a chance to get something like this approved and licensed, or do we have to go somewhere else first and show them how it's done?
Yeah, it's a really difficult question. So in the US, it's really the Nuclear Waste Policy Act and its amendment in 1987 that says that the waste solution is Yucca Mountain. and that nothing else is really going to be considered until Yucca Mountain is operational. Now, that's a decision that was taken in 1987, and Yucca Mountain was supposed to be operational by 1998. Obviously, it didn't happen. It's not moving forward currently. Nobody really expects Yucca Mountain is ever going to happen at this point. So we've dug ourselves into a really difficult situation here, especially because nothing else can be considered until Yucca Mountain is operational. Now, that said, there are some gray zones that we can work in. Commercial spent nuclear fuel in the US, or rather, I should say, existing commercial spent nuclear fuel in the US is destined to Yucca Mountain. Now, there are other types of waste that don't necessarily have that same limitation. So there may be other places we can start. New reactors, similarly, it's not as clear that the waste they're generating or going to be generating has to be sent to Yucca Mountain. So there are some places we can work with within the United States. We can also look at underground temporary storage as an option. So putting the waste into boreholes, but saying it's going to be retrievable until we can get the regulations and the law changed, really. And I think once we have a success, then I think things will start to get easier to change. Again, it's about starting with the easier lift. And I think changing the Nuclear Waste Policy Act amendment right now is just too difficult. But if we can get a success, and maybe that'll be in the US for something other than existing commercial spent nuclear fuel, maybe it'll be in Europe or in other parts of the world where we do have active projects and conversations happening now. And I think once we've done that, once we have that success, then we can come back and figure out how to move things and change things so that it can happen in a commercial way in the United States as well.
Gotcha. That makes sense. Great answer to a tough question.
We've dug ourselves into a really tough situation here in the US.
That's true, but you're going to dig your way out by literally digging more holes, right?
Yes.
Okay, I want to switch gears just a little bit and talk about the broader nuclear industry, but also how your company plays into that. Yeah, one critique that I've heard and I sympathize with about the nuclear industry is that there's a strong propagation of radiophobia, and it is the biggest threat, but also the biggest moneymaker for the current or existing nuclear industry because we're not building more plants. So the only thing left to sell is safety upgrades, which is selling fear. But then when I look at the science around like spent nuclear fuel and the actual hazard that it presents, my read is it's dangerous for about 600 years, but after that, we should be able to hold it, and it'll only be dangerous if we eat it. Therefore, don't get it in the water table and treat it like any other poison. Yeah. So there's kind of two questions here, but I want to start with the radiophobia piece. Your business is built to dispose of a toxin effectively, but my concern is that it might spread more radiophobia. If this is super dangerous, why do we have to get rid of it? And if it is creating more toxins, then we can't build more nuclear, and so we'll just close plants, and that's bad for your business, right? This feels like a double-edged sword. So how do we address that?
Yeah, there's a lot to that question. So let me try and pick it apart little by little.
I talked a lot.
Some of the pieces, ask me again.
Yeah.
I think the radiophobia is really unfortunate. And I think that, again, I got into this because I want to see a future for the nuclear industry, and I think we need it if we're going to combat climate change. So this is not just about dealing with nuclear waste, or even really about making nuclear waste safer than it is today. It is about making it safer for the next generation, right? So there's that second piece in there. And nobody really thinks that temporary storage is going to be great for 1,000 years. There are arguments that you can do it for temporary storage and then it's not so dangerous anymore. And sure, all that is true. You do have this, you're dependent on institutional controls, as we've all seen over the past year. You don't really want to be dependent on institutional controls, and you shouldn't need to pass on the problem to the next generation. We should
Can we define that a little bit? Institutional controls meaning the existing laws and governments and social and societal structures that we built today.
Yeah,
Am I thinking about that
yeah,
right?
right. So if it's in temporary storage, you're going to have to check for degradation of the concrete, for example. And as it degrades, which it will, you're going to need to put it in a different container, which is fine. That's all doable, right? You can put it in a different container. You can keep it very safe. You can have everyone shielded while you're doing the changes. But if you're no longer in a situation where the government is an institution that you can trust, right? Maybe there's a terrorist who potentially gets a hold of it. There's a proliferation risk. We don't know what our world is going to look like a couple hundred years into the future. And so having any situation where you're dependent on the status quo continuing for those time frames is concerning, potentially concerning, not necessarily concerning, but potentially concerning. And so if you have a solution and a way of just eliminating that potential risk and saving some money, significant amount of money at the same time, why wouldn't you just do it? It just makes more sense. It's not, that's one thing that I think bothers me in the nuclear waste discussion is this concept that nuclear waste disposal is so hard that we have to explain why we don't need to do it. And a lot of people have put a lot of effort into
Like
explaining
nobody else does that.
it's not that hard.
Yeah.
And I think if we as a country or our government put the same sort of structures in place to encourage innovation in nuclear waste disposal that we have, to encourage innovation in advanced reactors or to encourage innovation in fusion, if we had incentives and reasons for people to come up with great ways of nuclear waste disposal, I think what we would see is that this is not that difficult a problem. And there is really absolutely no reason that we need to think about temporary storage for hundreds of years because we could put it in disposal 5 years. And it just doesn't make a lot of sense to explain why it doesn't need to be done unless you're assuming it can't actually be done, which is, I think, an assumption that still a lot of people have when they think about waste disposal.
Technically, if we wanted to do it, any company could just go and dispose of it tomorrow, technically. But yeah, I think the problem that you guys are solving here is addressing a societal perceived problem that has been associated with nuclear energy for all of nuclear energy's existence, which I think is excellent, right? It's providing a viable solution that is economic and cost competitive and can be done anywhere. I think it's awesome. I asked a senator in Colorado, a state senator, that voted no on including nuclear under the definition of clean energy. This was recently this year. I asked her, what she was afraid of, and she said she's not educated about it. She said, what about the waste? And I brought up your company, and I said, there's actually a company that's addressing, and the waste isn't that dangerous. It's never hurt anyone ever, but there's a company that's going to bury it 2 miles underground. And she immediately asked, if it's not that dangerous, then why do we have to bury it 2 miles underground? I'm curious on your response to her question.
Yeah, I hate these people who also say the waste isn't dangerous. The waste isn't dangerous as it's shielded and protected from the world today. But if you just had the waste sitting in your hand, it would kill you. So there's nuances here. And that's, I think, what's so difficult about the nuclear industry is all the different levels of nuances. So the waste today, as it's being handled today, is not dangerous. And I completely agree with that. It's not dangerous as it's being handled today. But that doesn't mean it's not dangerous, right? It doesn't mean you don't and shouldn't put it in disposal where it's going to be safe for the very long term. But that level of education, that's not something you can just put easily on the back of a bumper sticker and get people to rally behind. It's all these levels of nuance, which is, I think, one of the reasons for the radiophobia and people fearing what they don't understand.
That makes sense. Yeah, it is. I agree with you. It is immediately dangerous, but we have engineered systems that we understand how to manage these things, right? And it's okay. Bleach is dangerous. Living in a tall apartment building is dangerous, right? These are driving is dangerous, but these are industrial or everyday things that we do that we understand the hazards and we know how to treat them. So how do we do that? It sounds like what I heard from your answer was there needs to be an education campaign of some sort to change hearts and minds and help people understand it because it's nuanced. But how do we best do that? How do we change the hearts and minds of members of the public about waste?
Yeah, I think the really remarkable thing that's happened over the past 18 months is that is already happening, and the hearts and minds are changing faster than I could have ever believed possible. What we're seeing now, and yes, this is in large.
Thank you for your contribution to that, by the way. That's, I think, what your company is
Well,
doing, and all of your publicity, your efforts, and willingness to be on podcasts and speak publicly about this is very helpful.
thank you. I think what I'm really referring to, though, is global warming and energy independence. So I think those two things have combined in a powerful way over the past 18 months. And we're suddenly seeing people who are openly supportive of nuclear power in a way that previously maybe they were under the table about. So still maybe supportive of nuclear power, but afraid to say so. And what we're now seeing is a global pro-nuclear environmental movement with people saying, we need nuclear. There's no way around it. It's not the only solution. Yes, solar and wind and all those great stuff. We need that too. But nuclear has to be there. We have to.
On this podcast, we have a different opinion about solar and wind.
Oh, okay. Okay. I like solar and wind. I may not be, we can get there all the way, but I'm not going to get rid of them. But I do think that,
Yeah. Right tool for the job.
Right tool for the job, and nuclear's got to be part of the mix. And if you see the way that young people are thinking about nuclear now, more and more are really very supportive, and that is changing. It's changing fast. So I still think education is important, particularly among people who may have been part of the older generation and who maybe have a fear of radioactivity. My dad likes to talk about how he's a wine fan, and so he likes to explain how the wine that you drink is radioactive, and it's required to be radioactive so that it doesn't come from oil and gas. And it's true. Everything we eat, you're radioactive, I'm radioactive. Radioactivity is something that's totally natural and it's everywhere. And so there is an education component too, but I also think there's a need. And when there's a need, people are more open to considering something that might be more nuanced than when there's no need for them to consider or to become more informed.
That makes sense. So if you can identify a need to educate people, then that's an interesting thought. Yeah. So I am curious. I asked you about communities earlier, but are there certain countries or parts of the world, and you may not be able to say, but that you think are most likely to adopt this technology first? I'll voice an opinion, and you don't have to agree or deny, but like Ghana is rated as the next country in Africa to get nuclear. I don't see why they wouldn't immediately just say, yeah, our waste solution is deep isolation. Welcome to Ghana. We are going to drill wells, and you guys are going to do it for us. Thank you.
Yeah, I think there's a couple of places that I think are feeling the most urgency around solving the nuclear waste problem. New nuclear countries is certainly one of them. So the concept of figuring out how you're going to dispose of the waste before you build the reactor is one that we're seeing a lot of right now. And it makes a lot of sense. The old generation of
cradle to
build a
grave
reactor,
engineering,
generate
right?
waste, and then later figure out what to do with the waste. It just doesn't make a lot of sense. Figure out what you're going to do with the waste. We're working with a group in Estonia that would like to do this, and they want to site and license the disposal facility before at the same time as they're siting and licensing the reactor that they're talking about building in. That's a really nice way of doing it, and we're seeing a lot of interest from people who want to build new nuclear power. The other space where we're seeing a lot of interest is around energy security, and some of these bigger nuclear countries that not just energy security, but also global security and concerns around, is the waste really going to be safe when you have a war going on next door? And I think it is. I think the waste is safe in dry casks and on the platforms where it is right now, but it doesn't change the fact that people would feel a lot better about it if it were deep underground, not dependent on institutional controls, safe for the very long term. So I think that's another space that is interesting right now, where people really appreciate the benefit of putting the waste deep underground. Another one that I'll mention, which is also pretty interesting, are people who are looking at mined repositories plus boreholes as a way of decreasing the cost and improving the safety of their mined repository. So this is, it's not intuitive, and you might think that how could mined repository plus boreholes be cheaper than just mined repository? But if you take the hotter or the worse waste out of the mined repository, you make it safer for the workers who are underground. You don't have to necessarily have some of the engineered barriers that you might otherwise have in the mined repository. You can instead put in boreholes right next to the mined repository, and it can save a significant amount of cost in addition to improving safety. So that's another area of significant interest right now.
I'll say it back to see if I heard that correctly. You would take high level waste, or the highest gamma and beta emitters, meaning like kind of the most dangerous or most penetrating radiation, reserve boreholes for those solutions. And if you already have a mine, or perhaps an old mine that you can repurpose for the low level waste, there's fewer engineered barriers that have to be behind that. It's easier to handle. You can dispose of it, presumably just take it down in the truck, drop it off in an old mine, and call it a day. Am I thinking about that correctly?
Yeah, it's the right general approach. Obviously, there's some nuances in there too, and
There's
differences
nuance.
depending on the waste. But yes, that's the right general approach.
Okay. So you guys are using a existing technology to solve what's really a social problem, and it's leading to licensing. But what do you think the fastest path to licensing in the U.S., or I'll let you say any other country is? And I feel like you kind of already answered this question a little earlier in the interview, but I am curious. Perhaps a different way to ask it would be, what are some of the hurdles that you have to overcome in order to get licensed?
Yeah, the licensing is going to happen. There are regulations that exist now that we expect to be able to meet. Now, there's going to be quite a detailed process to go through. But again, mined repositories are good enough to meet those existing requirements. And we're going 3 to 5 times deeper than mined repositories, and we don't have humans underground. So we really have no concern that we're going to be able to meet those safety requirements. We will meet those safety requirements by a pretty significant order of magnitude. We're looking at being 1,000 times safer than the existing regulatory requirements. So we're confident about that. Now, it's going to take time. It's going to take a couple of years probably in order to really go through that process. I do expect that the big hurdle is not so much the regulatory process, which I feel very confident about, even though it will take time, but getting those first customers to say, yes, go, run with it. We want to use deep isolation. We want to have a borehole repository. Our customers have told us that they want to see an end-to-end demonstration before they sign on the dotted mark. And that's one of the reasons that we're doing.
What's that mean? Like you show the whole process, maybe without an existing fuel rod, and you can show that you can load a wellbore with your canister.
Yeah, that's it, precisely. We did a demonstration in 2019 that was sized for cesium and strontium or CANDU reactors. So these are wastes that's much smaller. So we're talking about a couple inches in diameter, and they would fit into a 4-inch canister that would fit into a 5-inch borehole, which is very standard. And so we did a demonstration in 2019. At the time, we weren't trying to show really that we could do end-to-end handling. We weren't trying to show that we could drill a hole specifically for this. We were trying to show that what goes down a borehole could potentially be retrievable, which people in the nuclear industry thought it couldn't. So there was this big nuclear industry, what goes down a borehole stays down a borehole. Now, anyone in the oil and gas industry knows
which everyone from oil and gas is. Sometimes it does stay in the hole, and we didn't want it to stay in the hole. This happens a lot, but yeah, but you can definitely get things out. It's called fishing. Right. We're doing it right now, literally right now. Location about half mile that way. We're actively trying to get something out of it.
Yeah. So the demonstration we did in 2019 really showed that we could retrieve something from a borehole, and it also showed that we could do a demonstration without public outcry. So the history of borehole demonstrations in the U.S. prior to deep isolation was pretty sad. There were a lot of protests. There was a lack of trust. There was NIMBYism. And when we were starting out, people said, there's no hope of doing a demonstration in the U.S. Don't even bother. Don't try. You're just going to be protested out of wherever you try to do this. And so in 2019, when we did this, that was the other thing we were trying to show, is that a private company doesn't have the same limitations as the government. We can go and do stakeholder engagement early. We can do it right. We can make sure we're building trusted relationships. And that's something that we take very seriously as a company. What we're looking at now, so what our customers have told us they want to see is more than that. So it's not just about what goes down a borehole you can retrieve and having a community that welcomes you in for a demonstration. It's also about the end-to-end engineering and showing that you really have the instruction manual with everything figured out from the beginning to the end. And this includes the larger laterals. So we're talking about 18-inch laterals, which are not standard oil and gas holes.
They're not. Those are big holes.
Those are big holes. We're working with partners who are very comfortable with that, who've done holes like that before. Our customers want to see it drilled specifically for us, not for other purposes. And so that's what we're demonstrating together with the surface handling. How do you get this out from where it is into the canister, and then from the canister to the top of the borehole? How do you lower it down? It's also integration between the nuclear industry that does the surface handling and then the subsurface, which is going to be handled by our partners on the oil and gas side. And so working through those handoffs and the integrations is really what we're now trying to show at this next stage of demonstration.
That's super cool. Yeah, I wish you guys success in that. I think there's an argument to be made that there's some toxins that exist that could also leverage your guys' technology. I mean, like nuclear waste eventually becomes relatively safe. Like I said, my perspective is after about 600 years, it's like any other toxin or poison, but in that 600 years, this could be an effective shielding, but there could be other chemicals that could be additional customers for you guys, right? Just thinking about disposing of dangerous products and removing them from the biosphere. I think that you guys have bigger business opportunities, in my opinion.
Yeah, I think so too. Nuclear waste is a really big opportunity. We'd like to focus on where.
Oh yeah, you guys are a startup. You got to be laser focused as a startup. Yeah, just focus, solve this problem first, then you can move on to the next one. But when you're ready to think about the next one, I've got a lot of ideas about how you can market this. So.
Excellent.
Liz, this has been great. I want you to leave us with where you see this all going. Leave us on an optimistic note. You're building something awesome. We think you should be proud of it. But where's the nuclear industry going? What's the future look like?
Yeah. I think the world is optimistic right now. I think people are recognizing the importance of nuclear power going forward. I think we are leaning in, even in places that you might not expect. I live in California. We're seeing Diablo Canyon likely being extended. Yes, there are other places that aren't quite there. I know I've been following what's going on in Germany, which I think is what it is. But I think globally as a world, we're seeing that nuclear power has to happen. And people are seeing that nuclear waste, disposal of nuclear waste, is an enabler and just the responsible thing to do as we move forward with nuclear power. I think deep isolation, we've passed that point now where this is going to happen. It's a question of when, not if. And the timeframes, yes, are a little bit uncertain. There is a regulatory process that we have to go through, but it's not a particularly difficult one. So if you compare this to other pieces of the nuclear industry, where I think there's a lot more uncertainty and timeframes are longer into the future, I think within the next couple of years, we're going to start to see where this is going to happen and when this is going to happen. And I'm not talking about 10 years in the future. I'm talking about 3 to 5 years into the future.
That's super helpful. I can't wait to watch it happen. So we'll cheer you on all along the way.
Yeah, it was great talking.
Liz Muller, thanks so much.
Thank you.
Absolutely.
Great being here.